So if you watched the videos that I made about capacitors, you'll be expecting this next step, which is the phase relationship between the inductor and the resistor, the voltage, specifically the voltage across the inductor and the resistor. And magically, it turns out to be really similar. So again, we can draw our phase diagrams, our phasor diagrams. And what we find is, when we do this experimentally, what we find is that the resistor voltage follows that nice, beautiful sine pattern, and so does the inductor voltage. But the inductor voltage, if you can see here, when the resistor voltage is 0, the inductor voltage is at its maximum. And that changes. When the resistor voltage is at its maximum, the inductor voltage will be at 0. And so we can draw those phasor diagrams just like last time. There's our resistor voltage there, okay? Turning in a circle, nice and simple. And just like last time, here's our inductor phasor, and there it is at the top of its circuit. And we can combine those together to get the overall supply voltage, just like we did before. So I'm going to draw it big this time. But what we're going to find is that here's our resistor voltage, here's our inductor voltage. Okay, and oh look, I even managed to draw it nicely. There's our supply voltage. Okay, so what we find is, or what we can say is that the voltage across the inductor and the voltage across the resistor are out of phase. The inductor voltage leads the resistor voltage by 90 degrees. The supply voltage we can find using Pythagoras when we know these two things. Okay, let's move on then to talking about, because I'm sure you've guessed we're going to, talking about impedance. And so just like before, we're going to be considering what happens in our circuit, okay? And just like before, we've got our supply, but this time it's up here. Here's our supply voltage. Here's our resistor voltage. Here's our inductor voltage. Okay, sorry, it's gotten a bit uneven, but we can work with it. There's our supply voltage. Now we know that our resistor voltage is, according to Ohm's law, equal to IR. We know, because we just found out, and we're amazing, know that our capacitor voltage is equal to I XC, the reactance, XL, the reactance of our inductor. Sorry about all the times I've possibly said capacitance in this video. You're just going to roll with it. Our reactance of our inductor. And so we can say, well, in that case, our supply voltage must now also be equal to IZ, the impedance of our circuit. And we can figure what that is. Remember, I is constant in all of these, or is the same. So again, we can say, well, if this is Z, and this is R, and this is XL, then we can put them together and we can say, well, Z equals the square root of R squared plus XL squared. And we remember, because we just learnt about it, we remember that XL equals omega L. Okay, the reactance of our inductor equals the omega related to the frequency times by the inductance of our inductor measured in henries. Impedance, as always, measured in ohms. Okay, it's nice and simple. If we can figure out the impedance, we can figure out a bunch of things about our LR circuits.